my name is Simon. I work for ETH Node. That's one of the core dev teams behind working on the Graph protocol. There are people know that there are many more core dev teams, which I will introduce in that talk, and also what they're actually doing. Because the question is like, who of you knows the Graph? Please raise your hands. Okay, cool, that's good. Then who wrote already a subgraph? Nice, okay. Who wrote a substream? Okay. Who deployed their subgraph to the decentralized graph network? Cool. All right, so I see there is some stuff that we can go into it today. How's it going with the slides? Almost there. Woohoo! Nice. Cool. So we already had a little bit the start. So yeah, I would say like we can quickly do this with the graph today because I see that most people know. So basically you can think about the graph as this, right? So you have this weird chaos of transactions on the blockchain, and then through some magic, I don't know how this really works, it ends up being nicely sorted, then you can quickly query it, right? So it all starts with this idea of we have a front end fully decentralized, right? So the front end is deployed in IPFS, interacts directly with the blockchain, preferably on your own computer. Yeah, but there's a problem with this architecture, meaning like the blockchain is made and incentivized for data writing, so you pay miners, but not really for reading. If you want to read data from the blockchain, you go to this weird protocol which is called JSON RPC, which was never kind of designed for really powering front ends or data analytics and stuff like that. So the solution to this problem is basically you put in a data layer inside of it or between it that cares all of the data, that indexes the data for you, provides you a query access to that data. So you can have like front ends, data science stuff on top and everything, and don't need to mess around with this JSON RPC protocol. So that, as I said, so that makes the graph, so to say, on a technical level, the data layer of Web3 sits in between. The cool thing is also that it can index different data sources, so not only Ethereum, but also Arweave, near IPFS data, other EVM chains, Cosmos, and more to come. So that's it's very interesting when we look again at this one, that you can think of, you have one unified data layer that communicates with like every protocol that is interesting for your dApp or your protocol, and then have like one unified, simplified data layer on top that gives you access. So it's more or less how it should look like. So for the coders in here, so this would be the JavaScript code of getting tokens for one user, which is super slow. If you run this and a user has like 10 or 20 tokens, then you end up with like 1, 2, 3 seconds loading time just to display a simple token balance. It would be much better. We have like a really nice GraphQL interface, like here, you know, like very nice, very tidy, cleaned up. This is what the graph does because it leverages GraphQL. Cool. So more than a year ago, the decentralized network was launched, and since then it was possible to publish subgraphs to the decentralized network. As yesterday, these numbers might have changed. We have 225 independent indexes on that network. We have more than 10,000 delegators who are delegate their GRTs to the indexers to secure the network. We have 2,519 curators which pick the best subgraphs in the network to signal to the indexers which to index, and we have like 573 subgraphs published to the decentralized network. I mean, that's quite a lot. That's very good. So that's the current state of the network. Currently, only Ethereum mainnet is available on the decentralized network, but more chains to come, right? So that brings us to these truly decentralized dApps, because you now can actually decentralize also your data layer while publishing your subgraph to the decentralized network. And yeah, we already have some very, very brave pioneers of decentralization. So Jörn, for example, or Uma, which is here, they already published their subgraph to the decentralized network. So thank you so much. And these are the pioneers. Maybe a quick applause for them. This is still ongoing, so if you have a subgraph on Ethereum mainnet that you want to publish to the decentralized network, find me or Kyle, and we can actually do it right on the spot. So, that could be fun. Yeah. So now we see what the graph is currently, right? We have the decentralized network, we have the subgraph technology, which is heavily used, kind of an industry standard, but like there are a lot of problems, admittedly. So subgraph indexing, for example, is very slow. If you have a bigger subgraph, it's super slow. There's also the problem with like, oh, we only have one chain on the decentralized network. We want to have more chains. Or it's very hard to find high quality subgraphs because high quality subgraphs are usually written by their teams to power their own front end. But if you have a data science approach and you want to have like an overview over different protocols and data, then it's very hard to find good subgraphs. Then there are cryptographic problems in when I send a query to the decentralized network, how do I know that the response is actually correct? There are payment problems that say like, how do the indexers actually get paid when they serve queries? Because they say they serve a lot of queries. Currently on the hosted service, we have 1 billion queries per day, which are served by the hosted service. We want to decentralize all these queries to the decentralized network. Every query comes with a payment, with a price. So how can you cryptographically secure such state channels? These are questions that we explored together last week. So we had like R&D offsite, all the graph core devs came together, and I will show you some of the highlights of that week. So we have, these are the working groups, can I point? Yeah. So here we have the data APIs. That goes in the direction like how do we have the data, how do we index that data, and how do we publish that data or expose it to consumers. Then we have the indexer experience that goes around like tooling for indexers. How can indexers be quickly onboarded into the decentralized network? How can they set the right prices for the queries so that is fair, but they still have like a profitable business? Then the whole protocol and network operations, the game theory behind it, like how does signaling work? How many need to do staking? Also, one of the outcomes here is we migrate the whole protocol, or like the main parts of the protocol, to Arbitrum to save up to 50 times of gas cost when you interact with the network. So this is good, this is coming. Then we have the Snark Force. It's probably more than just Snark. It's the cryptographic security researchers. There's a group across core devs that really go deep into these topics that I tried to outline before. And yeah, the protocol economics talk. All right. So these are the highlights. So network multi-chain support, as I said, like we currently have only Ethereum mainnet on the decentralized network. So like more networks to come. Announce this Gnosis chain as the next network. So if you have a subgraph on Gnosis chain and you want to be on the first to migrate, also reach out, I'm here. Then we have Firehose and substreams, which is the next topic. These are the big new improvements that came from Streaming Fast. How to extract and process data from the blockchain like much more efficiently. They saw an increase of indexing speed of 100x. This is very cool. We will go in that detail. Then there is the graph client by the Guild. Which helps in the front end to build stuff together, to stitch those subgraphs together, to get more data, enrich the data, make data streaming available, and very cool stuff. Then there is the Indexer Launchpad. As I said, it's a Kubernetes thing that you can easily run up and then launch a very high scalable indexes across multiple machines. Then there are the Messari subgraphs, which are standardized subgraphs across all the protocols and all the chains, which we'll look at them. Then scalar payments, which go into the direction of how can the payment flows to the indexers be more efficient, and in terms of one participant goes down, then it's still possible to withdraw these thousands or millions of simple receipts. Then AutoAgora, which stands for like price finding mechanism with AI, so that each indexer can get into account how much infrastructure costs they have and how much they need per query to serve that query efficiently to the user. And then in the end, like one of the biggest topics, but that's a little bit far out, are verifiable queries. So you have a cryptographic proof when you receive a response from an indexer that you know it's right. Because the data that's indexed is deterministic because it comes from chain, so it's theoretically possible to prove it, but it's, yeah, I mean, the math behind, it's a little bit above my brain size. And all this is facilitated by these 6 core devs that we have, like Edge and Node. That's the company that I work for, which works on the graph node and the protocol mainly. Then we have Streaming Fast, which really focused on this streaming, data streaming approaches for getting data out of the blockchain. Then we have Graph Ops, which help with the indexer launchpad, but also some cryptographic research. They do semiotic AI, also very into cryptography and what is the other? Machine learning, artificial intelligence. How can we apply this on the decentralized network? Then we have the Guild. These are front-end wizards that are like very best-in-class GraphQL developer, and they're building the best tool to actually then consume that data. And last but not least, Messari, which doubled down their whole data science team of using subgraphs, writing subgraphs, and then really give tools, especially for Python people to visualize that data. So very cool. So let's start. So we have these 3 pillars of success for networks. It's quality of service, cost of service, and developer experience. Let's start with substreams. So substreams might be the most interesting technology when it comes about data extraction from the blockchain. So a subgraph, you can quickly, I copied these slides from Alex, the CTO of Streaming Fast. He had a talk at DevCon. You can also watch it online if you want to go a little bit deeper, but I give you just a quick overview. So you can see as subgraphs basically as a ETL queue pipeline, so extract, transform, load, and query data. So we have this JSON RPC polling, the WebAssembly, or the assembly script, mapping that takes that data, stores into a Postgres database, and then opens up through GraphQL. So these are subgraphs. They are industry standard, they're good, but they have problems, especially in this loading and storing phase. So what substreams do, like, it's a completely different new approach. They rethought the whole process. So first is the firehose. So the firehose extracts data from the blockchain directly, not through a JSON RPC interface, but by flat files, just writes everything down. The cool thing about flat files is that you can parallelize this thing and really stream it out, right? So you can have this file output stream that you send across multiple servers, across different data sources, and that makes it much faster to index and parallelize. And so you have this stream of raw block data that you can really go into anything that's in there. And then you have substreams. Substreams consume that stream, and start to work on that stream in a MapReduce fashion. So you can filter and refine that stream of data so that in the end you only have the stream that you're really interested in. Let's say you want to write a substreams for NFT transfers, then you would filter for only the NFT transfer event signatures, and then only take those. And then when you see one, then you add just this one thing that you want to do in your store. And then the cool thing here, it's highly parallelizable, right? That's the word. So these are the 2 main things. We can also go a little bit into substream. So that would be how it looks like. So it's all written in Rust. So who's a Rust engineer here? So the technology choice, yeah. I mean, I would say everybody needs to learn Rust, right? It's the best language. Yeah, so how does it work? We have the block, and the block can be filtered for these pairs and pools, and then for the prices, and then in the end aggregated again in like one aggregated pricing stream across all these AMMs. That could even then be extended. So the cool thing about substreams, you write modules, you write very small modules that you can then plug and play with each other. So you could also then bring in the OpenSea sales, which then ends up with you can end up with a USD per collection. That gives this parallel execution of the store. I see I'm a little bit My time is short, so there's so much to do here. So we have on-chain data from Messari. So they had this problem that they looked at all these different protocols and wanted to compare the data. They looked at the industry and they saw like, you know, different data sources, and then like sometimes you have like double data sources which are maybe even like contradicting, or you have like even some is missing because not everything was there. So they went out to create this standardized subgraphs across all these protocols, which are all having the same attributes and schema in there. So, and they make these categories. I think one is lending, then you have AMMs, then you have others. So I think 5 categories, and then across all chains, they've always wrote the same schema, so you can simply compare all these protocols to each other. I think it's more than 200 subgraphs, high quality subgraphs that they wrote. You can check them on subgraphs.xyz. And then also they create these data apps which then consume that data, and you can visualize it. And they create, they are working and soon release a Python library that helps you to build streamlit websites, which they call data apps, that consume that data and display that data to the users. So that's a very powerful thing that also their data scientists, which are into Python, can start to write these data apps and publish it to the world. So that's very cool. Also, yeah, so I see some examples. Also, there is the protocol metrics UI that you can already go to on the Messari page. It's public. The data apps are currently private beta, but they will be open source. Yeah, that looks something like this. So for all these protocols, you can explore the protocols, and then you can see the charts, and you see what was going on. And this is also powered by the Messari subgraph. So very cool stuff, like very easy to engage with technology from the graph before you need to be able to write subgraphs or know how to consume subgraphs in GraphQL. But now you can use the graph basically by using the subgraphs of Messari. So this is very cool. Then we have the next big thing is the graph client. Who is a front-end engineer in the room? Or like full stack also front-end? Yeah, most people in Web3, you know, are like into contracts and game theory. But if you wanna get the rest onboarded, we need to have like great UX with great front-end. So that's what the graph client helps here. So querying data from the graph from the front end, I mean, yeah, you can do it. It's okay. It's a GraphQL interface, but there are a lot of features missing or hard to implement that you are usually that you expect if you're experienced with GraphQL in Web 2. So what the graph client does for you is like, regardless how many data sources that you consume, regardless how many different subgraphs, or even if you have some Web 2 data source that you want to bring into your front end, or you have some direct access to the JSON RPC, you can use the graph client that brings this all together into one uniform single GraphQL schema, inclusive mutations actually, that you can load into your in the browser. So it's like a server that runs in the browser. So you can still have fully decentralized apps, but kind of build upon this experience of having like one unified schema that is usually the case when you write front-end tabs. So quickly, what are the features? So like they have end-to-end typed queries, so they can auto-generate SDK functions for you out of the queries exposed by your subgraph. Then you have live queries. That means like it helps you that you can write the front end, and whenever the underlying data changes on the blockchain, your front end automatically updates. Then you have automated block tracking, which goes a little bit to the live queries, that the front end is aware about the current block, and according to that can send a query if needed back to the subgraph without actually interrupting that much the rest of the computation. Then you could query multiple subgraphs at once, right? Like a lot of protocols nowadays, they have the same subgraph deployed to different chains. And that makes it in the front end sometimes quite challenging to bring that back together and know what's going on. So like the graph client can just say like, okay, these are my subgraphs, and then it builds you automatically a unified one schema on top of it. Then we have automated pagination. which helps you when you want to query data from the graph. It's usually a little bit hard to go through all these data sets because it's big data sets and you cannot just download, terabytes of data from it. So that the graph client also helps with that. For the Python world, it's the Messari stuff that helps with pagination. So we have like now Python and JavaScript very well covered. Yeah, and the future of the graph client, actually I didn't get this in, but the future of the graph client is even better query mechanisms where you can say like I load data that's quickly loaded, and then later on load the data that is a bit slower, so you can have snappy interfaces with several steps data loading and that kind of fancy stuff. So that's very cool. So if you're into front end, definitely check that out. I'm also here today and tomorrow, and happy to dive deep into your front-end stack. That's where I come from. That's so I'm so excited about this because my path into Web3 was through front-end. So putting it all together, again, I think summary: there's a multi-chain network, Firehose substreams, like really extracting that data. Then the graph client, how to consume that data. GraphCast is something we didn't talk about, right? That's from GraphOps. It's the idea that indexers should also exchange data with each other. They should exchange data about which blocks did they see, about what was the data, and maybe if there are differences, they can negotiate already, like why did you see different data than I have. Indexer Launchpad, we talked about the Messari subgraphs, scalar payments. Yeah, these are like the highlights. So in the end, all the stuff gets harder, better, faster, and stronger. But like we have the better trust guarantees, better developer experience, better query processing, and better uptime guarantees, which makes the graph. The data layer. Thank you so much. Oh, can you leave the QR code for a second? So people might want to follow me on Twitter or just send a DM. And I think we have time for questions, actually.
Yes. Is there different clients? Like on Ethereum, you have different clients that you can run. Do you have the same at the graph? As for the, yeah.
Yeah. If you want to read query from the data from the graph, you do not really care actually which chain is indexed below because it's just GraphQL, the thing. When we look at the extraction. The graph node that's in current implementation, it usually communicates with JSON RPC. So like every EVM compatible chain is compatible, so to say. But the substreams is a little bit, or Firehose is a bit more complex because you would need to patch the underlying graph node to actually bring that data out in that stream. And I can't recall from my head, like it's definitely done for Polygon, Ethereum, I think also Solana, and others, yeah.
Okay, thank you.
Hi, what's the future for hosted services with the graph network coming about? So for chains, not Ethereum chains, will there be an opportunity for a smooth transition?
Very good question. I should have actually included a slide for this. Thanks for asking. So the hosted service will degrade over time, but only as soon as the network is actually good and stable enough. So far, we had, there are like, especially with the billing process, it's quite cumbersome. You need to bridge it to Polygon and load it into a contract there. So we are working on improving this. And as soon as we are confident, the community is confident that we can now do the step together, then we'll slowly and surely deprecate chains on the hosted service as soon as they are really ready and production ready on the decentralized network.
Hey, I'd like one question, because one of the things that you mentioned with the new GraphQL client is the fact that you could query multiple subgraphs. And this is generally one of the biggest pain points of having schema stitching or federation. What are your plans on solving this?
I can show you how it goes. Yeah, you can go in the graph client, you just define which schemas you want, and if they are the same, it really helps you to sketch it together automatically. Yeah, the graph client, like, you should try it out. It's very early. But yeah, I already made some good experience with it.
The Firehose product, that's streaming, right? That doesn't require indexers.
No, not currently not. It's just
Right.
the technology how to extract the data, and there's research going on how we then index. We bring this to the decentralized network.
Yeah.
But for now, the technology is there to just play around.
So you have to, so like in current like a subgraph, like it's good that the person who writes a query and the person who runs it are separate with index and that. But for this Firehose, basically you have to write the query extraction layer in Rust. Then also you have to host the kind of processor to process.
Yeah, currently the streaming fast provides you a playground to do this, and eventually we will have this in the decentralized network. So you will then send your substreams to the decentralized network, and then indexes from there will pick it up and do it for you.
Okay, thank you.
Okay, guys. Thanks a lot. Thank
Thank
you,
you so
Simon.
much.
Great talk.